we're going to be doing an ice cream lab. Everybody's going to be making ice cream, but in order to eat the ice cream, you got to first complete the pre-lab. The pre-lab is in claim and justification form. To make a claim, you'll write a justification for that claim, but you also have to have the math to support that justification. So here's what you have to do to qualify to eat the ice cream as part of the ice cream lab. Given the following information, you have to determine whether 3,250 grams of a saturated salt solution, that's dissolved in water, at its freezing temperature can freeze 900.0 grams of a sample of ice cream mix. This is also in liquid solution. If the initial temperature of the liquid ice cream is also at its freezing temperature, the freezing temperature of salt water is not the same freezing temperature as the ice cream mix. Now your answer needs to include a claim, a clear justification for that claim, and you have to show the math to support that justification. Here are some of the values you need to know to solve the problem. You need to know the mass of the ice cream mix, that's 900.0 grams. The enthalpy of fusion of the ice cream mix, that's 155 joules per gram. Now the beginning temperature of the ice cream mix and its freezing temperature are the same. You're assuming this ice cream mix has been cooled down to its freezing temperature but has not yet been frozen. You need to know the mass of the saturated salt water, that's 3,250 grams. The heat capacity of the saturated salt water, 3.98 joules per gram per degree C, and the initial temperature of the saturated salt water, negative 21 degrees C. Now on the handout, this is what the values for the ice cream mix look like. Just notice the enthalpy of fusion is in a fraction, 155 joules over grams. And this is what the values look like on the handout for the saturated salt water. Just notice the heat capacity, it's in a fraction, 3.98 joules per gram per degree C. So let's take a minute and talk about the idea behind making ice cream. So in a typical home ice cream maker, to make homemade ice cream, you've got an inner container like this where the ice cream is put. And this is usually a metal-sided ice cream container, has a top on it. And then you put in another container, it's like an open bucket arrangement, where you put ice cubes, salt, and water. So the ice cubes, salt, and water are out here. And the whole idea here is the transfer of energy. Q is heat energy. So we're transferring heat energy from the ice cream mix to where the ice cubes, salt, and water are located. Now, most of the home ice cream makers actually have a crank on the top or a motor that actually turns it, keeps it stirred up. There's a paddle inside here that stirs up all the whole mixture regularly. But the concept is just like the calorimetry problems we've done, the thermochemistry problems we've done, where we're transferring energy from one place to another. Now the ice cream maker we're going to be using is more like this, where the ice cream mix is put into a container like this, and it's fixed inside a large plastic ball. We put ice, salt, and water here. The basic idea is exactly the same, however. We're transferring Q, heat energy, from the ice cream mix into the area where the salt, water, and ice cubes are located. And that's the basic idea. So the pre-lab homework you have to do is to figure out, is there enough capacity to take out that energy in this salt water solution? Now I sort of simplified the homework. So we just said we had a saturated salt water solution here, or here in the outside of this. A saturated salt water solution has been cooled down as cold as we can get it before it freezes. So it's a liquid, and we've got the ice cream mix cooled down to its freezing temperature, but it's not been frozen yet. The only question you've got to ask, and you have to do it, to answer it using the math problems you've learned to use in this unit, is can this salt water mixture take up enough of this heat energy to freeze this ice cream? That's it. Is there enough capacity to take up that heat energy, transfer that heat energy from here to here? Can it be done to a large enough degree that we can freeze this ice cream mix? If the answer to that is yes, that's what you're going to claim. and your justification is, this is how I know it, and explain it in clear, convincing detail. And then the math, where you show how you calculated that, has to be part of your explanation. You have to have the math to show it. Your justification is not the math. The justification is a sentence or two or three or four, whatever number of sentences you need to justify your claim. So a claim can be a single sentence. Justification, it might be a single sentence, but I suspect it has to be more than that to fully explain, to thoroughly and clearly explain how it is that you believe that there's enough capacity to take up the heat in the salt water mixture to completely freeze the ice cream mix.